Hi everyone, welcome to today's GCSE Foundation Revision video. It's 97 days to go into your GCSE Maths exams, and in today's video we're going to go through the topics of multiples, factors and prime numbers. And it's really important you know what these terms mean and you're able to answer questions on them. If you've got the revision cards, there's revision cards on multiples, that's card 34, factors, card 35, and prime numbers, card 36. And those revision cards will be useful for you. But as I said, it's really important you know what these terms mean and you're able to answer questions on them. So in this video, I'm going to go through what they mean. I'm going to go through some examples and you're going to have some questions to try yourself. And I hope that you find it useful.
So let's start off by looking at multiples. So here's part of the Corbettmaths revision card, and the multiples of a number can be found by multiplying that number by whole numbers. So for instance, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and so on. So the multiples of 4 would be 4, 8, 12, 16, 20, 24, 28, and so on. And to find the next multiple for you, just keep adding 4, and that's it. Okay, so here's two questions. I'm going to go through these now. If you want to give these ones a shot yourself, feel free to pause the video and then check and see if you got them right. Okay, so the first question says list the first 5 multiples of 7. So the first 5 multiples of 7 would be 7, the number itself, and then 7 plus 7 is 14. Add another 7 would be 21. Add another 7 would be 28. And add another 7 would be 35. So the first 5 multiples of 7 would be 7, 14, 21, 28, and 35. Okay, next we've been asked to list the first 5 multiples of 12. So let's start off by writing the number itself, 12, and then the next one would be 24, and then adding another 12 would be 36, add another 12 would be 48, and adding another 12 would be 60. Or knowing the 12 times tables, they go 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, and so on. So the first 5 multiples of 12 will be 12, 24, 36, 48, and 60. Okay, so we've looked at multiples. Now let's have a look at common multiples. So common multiples are very useful whenever you're doing topics such as adding fractions. And we've been asked to write down 3 common multiples of 6 and 9. So let's start by listing the multiples of 6. I'm going to write down the first 10 multiples of 6. So we've got 6, and then 12, add another 6, 18, 24, 30, 36, 42, add another 6, 48, 54 and 60. And if we need to go further, we can in a moment. And then the multiples of 9, let's write down the multiples of 9. So the multiples of 9 would be 9. 9 times 2 is 18. 9 times 3 is 27. And I'm just going to keep adding 9s here. So 36, 45, 54. And then we've got 63, 72, 81, and 90. And again, if we need to go further, we can. So there's the first 10 multiples of 6 and the first 10 multiples of 9. Now let's look for some common multiples. They're numbers that will be in both of those lists. So I'm just going to change the color of ink here to blue. So the common multiples of 6 and 9, well, if we have a look here, we've got 18 is in both of the lists. So 18 is a common multiple. So a common multiple of 6 and 9 would be 18. And that one's actually called the lowest common multiple because it's the first one. Let's have a look for some more common multiples. So 24, no, 30, no, 36. As you can see, 36 is in both of the lists. So 36 is a common multiple. And then if we carry on, 42, no, 48, no, 54. So 54 is a common multiple, and so on. So there's the first 3 common multiples. Now the question just said write down 3 common multiples of 6 and 9. So you could have written down larger common multiples, but the first 3 common multiples of 6 and 9 would be 18, 36, and 54. So they're the common multiples that I'm going to write down. 18, 36, and 54. And if we wanted to find the next one, we could just add another 18, which would be 72, and so on. So that's common multiples. Let's have a look at a question now yourself. So here's a question for you, and the question says write down 3 common multiples of 4 and 10. So have a go at this now, pause the video and have a go at this one. Okay, so let's have a look and see how we do this question. So if I was to do this question, I would list the multiples of 4, so 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and so on. And then the multiples of 10, 10, 20, 30, 40, 50, 60, and so on. And we've been asked to find 3 common multiples of 4 and 10. So I'm going to look at the lists and look for any common multiples. So that's quite nice because it's common multiples of 4 and 10. Because we're dealing with 10, we know that all the multiples of 10 end in 0. So if we have a look at the multiples of 4, 20 is in that list and 20 is there. So 20 is a common multiple of 4 and 10. 40 would be another one, and the next one will be 60. Every single time we've got a common multiple, it's going to be another 20 in this list. So it's going to be 20, 40, 60, and you could have gone for bigger common multiples. You could have gone for 400, 800, 4,000, 4 million, and so on. But the three common multiples that I've written down are 20, 40 and 60. And even though we haven't got to 60 in the multiples before, if you carried on, you would get to 60 if you wanted to, or you could just know that, well, the first one's 20, the next one's 40, then the next one will be 60, and then 80, and then 100, and so on. So that's it. Okay, so we've had a look at common multiples. Now let's have a look at the LCM, the lowest common multiple. And again, this is quite useful. So the question says, find the lowest common multiple of 12 and 20. So again, what we're going to do is we're going to write down the multiples of 12, the multiples of 20, and then we're going to find the lowest common multiple, that first common multiple. So the multiples of 12 would be 12, 24, 36, 48, 60, 72, and so on. And then the multiples of 20 would be 20, 40, 60. And as you can see, 60 is in both of the lists. So the lowest common multiple, the LCM, is equal to 60. And that's it. So the lowest common multiple of 12 and 20 would be 60. Okay, let's have a look at a question now for you to try yourself. So the question says, find the lowest common multiple of 12 and 8. And feel free to pause the video and to give this question a shot. Okay, so if we want to find the lowest common multiple of 12 and 8, we write down the multiples of 12, which would be 12, 24, 36, 48, 60, and so on. We write down the multiples of 8, which would be 8, 16, 24, 32, and so on. And we're looking for the lowest common multiples. That's the first common multiple. So as you can see here, 12, no, 24 is in both of the lists. So the lowest common multiple of 12 and 8 would be 24. And that's it. So hopefully you got that right. Okay, so we've had a look at multiples, common multiples, and the lowest common multiple. Now let's have a look at a question in a context. So we've got a question here. It says, a blue light flashes every 9 seconds and a red light flashes every 12 seconds. And both lights have just flashed together. After how many seconds will both lights flash again? So have a go at this now. Pause the video and have a go at this one. So we know that the blue light flashes every 9 seconds. So the blue light flashes every 9 seconds. So if it's just flashed, it'll flash again in 9 seconds. It'll then flash again at 18 seconds, and then 27, and 36, and 45, and so on. The red light, well, the red light flashed, it's just flashed, so then it's going to flash again in 12 seconds, and then 24 seconds, and then 36 seconds, and 48 seconds, and so on. And the question is, after how many seconds will they both flash again together? And if we have a look at the multiples, we can see that 36 is in both of the lists. So that means if they've just flashed together, in 36 seconds time, they'll flash again together. So the answer would be 36, and that's it. So the lowest common multiple, it's a very important topic, not only for questions like this, whenever you're having to find the lowest common multiple in a certain situation, and have a look at the practice questions for some more questions where there's different situations, but also for topics such as add and fractions. So let's have a look at factors. So factors. The factors of a number are the whole numbers that divide into it without a remainder. So for instance, if we were asked for the factors of 20, what I would do is I would consider the numbers or pairs of numbers that multiply together to give you 20. So 1 times 20 is 20, 2 times 10 is 20, and 4 times 5 is 20. So that means the factors of 20 would be 1 and 20, 2 and 10, and 4 and 5. And I would tend to write them in order 1, 2, 4, 5, 10, and 20. So you can divide 20 by all of these numbers without having a remainder. So here's a question now. It says find the factors of 18. And remember, you can pause the video now and give this a shot. Okay, so we were asked to find the factors of 18. Well, I'd think of the numbers that would multiply together to be 18. So 1 multiplied by 18, and 2 multiplied by 9, and 3 multiplied by 6. So they're all the pairs of numbers which would multiply together to give us 18. So the factors of 18 would be 1, 2, 3, 6, 9, and 18. And they're the factors of 18. And that's it. Okay, so that's factors. Now let's have a look at common factors. And in this question, we've been asked to find the common factors of 12 and 30. So if you want to find the common factors of two numbers, what we would do is list the factors for each of them. So list the factors of 12, list the factors of 30, and then find and circle any common factors. So if you want to give this question a try now, feel free to pause the video and to give this a try. Okay, so the factors of 12. Well, for 12, we've got 1 times 12 is equal to 12, 2 multiplied by 6 is equal to 12, and 3 times 4 is equal to 12. So the factors of 12 would be 1, 2, 3, 4, 6, and 12. Okay, now let's have a look at 30. So 30, the numbers that multiply together to be 30. Well, 1 multiplied by 30 is 30. 2 multiplied by 15 is equal to 30. 3 multiplied by 10 is equal to 30. 5 multiplied by 6 is equal to 30, and that's it. So the factors of 30 would be 1, 2, 3, 5, 6, 10, 15, and 30. So there's the factors of 12 and 30. Now we're looking for the common factors, so let's look and circle any common factors. So 1 will be a common factor of 12 and 30, and actually 1 will be a common factor for any pair of numbers. And then let's have a look at any other numbers. So we've got 2's in both lists, so 2 is a common factor. 3 is a common factor, it's in both of the lists. Not 4, not 5, 6 is a common factor. Not 12 or 10 or 15 or 30. So the common factors of 12 and 30 would be 1, 2, 3, and 6. So they're the common factors. And this is quite useful whenever you're simplifying fractions and things like that, whenever you're looking to see what you can divide numbers by. Okay, so that's common factors. Okay, now let's have a look at the highest common factor, or the HCF. So the HCF, the highest common factor, is the largest number that both of the numbers are divisible by. So it's the highest common factor. So let's start off by writing down the factors of 24 and 36 and see what they are. So 24, the factors of 24 would be, well, 1 multiplied by 24 is equal to 24. 2 multiplied by 12 is equal to 24. 3 multiplied by 8 is equal to 24. And 4 multiplied by 6 is equal to 24. So the factors of 24, the factors of 24 would be equal to 1, 2, 3, 4, 6, 8, 12, and 24. So they're the factors of 24. Now we're going to do 36. So the factors of 36, well, 1 multiplied by 36, 2 multiplied by 18, 3 multiplied by 12, 4 multiplied by 9, and 6 multiplied by 6 multiplied by itself. So the factors of 36 would be 1, 2, 3, 4, 6, 9, 12, 18, and 36. So 36 has got quite a lot of factors. Now we're looking for the highest common factor. So let's circle the factors. So we've got 1, we've got 2 is a common factor, 3 is a common factor, 4 is a common factor, 6 is a common factor, 8 no, 9 no, 12 is a common factor, and then we've got 18, 24, and 36 no. So the highest common factor, the greatest number that both of these numbers are both divisible by, would be 12. So that means that 12 is the highest common factor, and that's it. So highest common factor is quite a useful topic. I'm going to give you a question now to try yourself. Find the highest common factor of 21 and 28. So feel free to pause the video now and to try this question. Okay, so the highest common factor of 21 and 28. So 21, the factors of 21 are 1 multiplied by 21 and 3 multiplied by 7. So 21 would be 1, 3, 7, and 21. In terms of 28, the numbers that you can divide 28 by, well, 1 multiplied by 28, 2 multiplied by 14, and 4 multiplied by 7. So the factors of 28 would be 1, 2, 4, 7, 14, and 28. Now we're looking for the highest common factor, so let's circle the common factors. There are 1, not 3 or 2, not 4, 7. 7 is a common factor, and none of the others. So the highest common factor of 21 and 28 would be 7. So that's it. So the highest common factor of 21 and 28 is 7. I hopefully got that right. Now let's have a look at prime numbers. So this is part of the Corbettmaths revision card, and a prime number is a number of exactly 2 factors, 1 in itself. So it's only divisible by 1 in itself. So 5 is a prime number because it's only divisible by 1 and 5. Its only factors are 1 and 5 because 1 times 5 is 5, but no other pairs of whole numbers will multiply together to be 5. So 5 is a prime number. But 9 is not a prime number because its factors are 1 and 9, but also 3 because 3 times 3 is 9, so 9 is not a prime number. And the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and so on. And it's important to learn those, to learn your prime numbers. I generally know up to 19 off by heart. Well, actually know a few more, but it's very useful to know those prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and so on. And I would recommend writing them down somewhere. If you've got window pens, maybe write them on your window at home, just so that you can, see them. If you're daydreaming, you can look at your window and see those prime numbers. But those prime numbers are very important, and I'd make a list of them or put this revision card somewhere safe. Okay, so let's have a look at a question for you now. Okay, so let's have a look at a question now involving prime numbers. Feel free to pause the video and to try this question out yourself, and whenever you're ready, press play. So the question says, Harry says all prime numbers are odd. Explain why Harry is wrong. Well, Harry's saying that all prime numbers are odd. Let's write down the prime numbers. So the prime numbers are 2, 3, 5, 7, 11, 13, and so on. As you can see, the first prime number is 2, because obviously 1 times 2 is 2 and it's not divisible by any other whole number. So that means that 2 is a prime number and 2 is even. So to explain why Harry is wrong, 2 is a prime and even. And that's it. So 2 is a prime number and it's even. So that means that Harry's wrong. And actually it's interesting to note that 2 is the only even prime number. So all the other even numbers, well, they're not prime apart from 2. And that's it.
And that's it. So we've gone through what multiples are, common multiples and the lowest common multiple. We've gone through what factors are, common factors and the highest common factor. And we've also gone through prime numbers. And it's really important you know those topics and you know what each of them mean, because not only are they useful on questions that you might get just on those topics, but they might be useful for other things. For instance, if you want to simplify fractions, it can be quite useful to find the highest common factor of those numbers, the numerator and denominator, to be able to simplify it. If you're adding fractions, it's useful to find the lowest common multiples to find out what the best denominator would be, and so on. So it's really important you know what those topics are and you're able to answer questions on them. So I hope you found this video useful. Remember, there's practice questions, and I'll put the practice questions in the description below, so give those a try as well. And I'll see you tomorrow, remember, at 3 o'clock. Okay, cheers, bye.